Okay, hello, assalamu alaikum. Can you hear me?
Assalamu alaikum. Yes, we can hear you properly.
Okay, just wait 1 minute, then we'll start.
Sir, I have submitted all the assignments earlier today. So can you check it out, please?
Okay, so I'll
You will
check
provide me with
and
the feedback.
okay, I'll send you the feedback soon. Okay, after the class, I'll send you the feedback. Okay, so we'll start today's session. So after completing the 3 hours live training, then we talk about the problem solving for previous class. Okay, so if you face any problem, then we'll have to discuss about this problem also after completing the 3 hours live training program. Okay, so let me share my screen. Okay, can you see my screen?
Yes, you can see
Okay,
every
fine.
screen.
Okay. So basically today's session to discuss about that mainly filtering and displaying the satellite images. So how we can easily filtering and displaying the satellite images and how to create the satellite composite. Okay. And also create the band combination. Okay. And export the satellite imagery, Landsat, Sentinel modes, or import, filter, reduce, clip, and display the raster data, time series analysis, export any shape file, and also cap about the annual image composite. Okay, so let's go start one by one. And before that, anyone have done idea about the remote sensing? Okay, so if I hope all of you already know about the basic remote sensing, these things. Okay, do you know about this basic remote sensing or not? And you have any problem about the basic remote sensing? Then I also try to teach you from the basic level, then move to the advanced. Know about the basic remote sensing or not?
I'm actually new
Oh,
to the remote sensing techniques.
okay. So,
So I do not have any prior knowledge.
okay, so I'll also try to show you that all of those from beginners, mainly remote sensing, how it will work. So all of those, we try to show you that again, no problem. So then you can easily get it. Remote sensing, how it will work. Okay, so let's start. Okay, so let me open my code editor. So first of all, basically remote sensing is the science of obtaining information about the object or area from the distance. Suppose without physical contact, we simply extract the information. Suppose now I am in Dhaka city, but now I want to make the land use land cover map for USA. Okay, so you don't need to visit physically in the USA to make the land use land cover mapping or any other types of analysis. Suppose vegetation cover or land surface temperature or water quality monitoring or air quality monitoring. So any other types of analysis without physical contact we can easily monitor. Okay, so remote sensing is the science of obtaining information about object or area from a distance. Okay, so this distance basically we are using the satellite, because satellite is available for the globally different types of satellite. Suppose if you just I show you the some satellite name. Suppose Landsat, it's one kind of satellite name. Then Sentinel, it's one kind of satellite name. Then Modis, it's one kind of satellite name. So not only for that, so there are a lot of satellites are available, and this type of satellite help you to, without physical contact, we can gather the information. This information can be different types of information. It can be, suppose, land use, land cover. It can be vegetation analysis. It can be land surface temperature. It can be water quality monitoring, air quality monitoring. So this is the basic things about the remote sensing. Without physical contact, we simply obtaining the information for an area from a distance, far distance. Okay, typically using satellite or aircraft. Okay, so now in the satellite have some key component. Okay, so I also send you some book about the basic books about the satellite or remote sensing, then you can read it, then you can get more better idea. So just I shortly discuss about the basic things about the remote sensing in this session. Then when you read the book, then you also get the more theoretical part about that. So in the remote sensing, we find out some key components. Suppose key components. First components, source of energy. Source of energy. Source of energy. Second component, atmosphere. Atmosphere. Third component of remote sensing is target. Then fourth component, it's a sensors. Sensors. Then fifth component of remote sensing is data processing and analysis. So basically, this is the remote sensing component. We find out that total 5 components. First of all, source of energy. This source of energy, it can be sun or artificial sensor you also create. So basically, Landsat, Sentinel or Modis, this type of satellite use the source of energy is sun. Okay, this type of satellite source of energy is the sun. Then atmosphere. Atmosphere basically medium of energy interaction. Okay, medium of energy interaction. Then target. So this target, so basically this type of Landsat, Sentinel or Modis, it's covered the whole earth or whole globe, it's covered. So this type of satellite easily covered the whole earth. Target basically earth's surface feature. So this type of Landsat, Sentinel, Modis, basically this target mainly for earth's surface features. Then what is the sensors? Sensors basically it's a collect reflected or emitted energy. Suppose sun reflect any kinds of feature, then it simply reflects some energy. Okay, this energy collect by the sensor. Suppose if you suppose I'll show you the some one figure, just a minute. Suppose remote sensing, I simply search remote sensing process. So if you check this image, suppose this one, I just open this diagram. So this is the remote sensing. If you check remote sensing process, so first of all, what happened? So this is our source. Okay, this is our source of energy. So from the sun, this energy, it's natural, but we can also create some artificial energy. We also create. Suppose lidar is one kind of artificial. So this is the sun. This sun basically it's natural source of energy. So we find out from the sun we find out the light. Okay, this type of light is reflected on the earth's surface. So this is our target. Okay, in the earth's surface it can be trees, it can be building, it can be water body or different types of feature in the earth's surface, we already know. And then second component is the atmosphere. So this is the atmosphere. So in the atmosphere, it's the medium of energy interaction. Okay, this atmosphere, yeah, sometime we find out the cloud. Okay, in the cloud you can see. So when I have a satellite image, this satellite image I find out the cloud. So then we don't find out the better imagery, because cloud is also hampered the satellite imagery. So that's why we also need to remove the cloud from satellite imagery to get the neat and clean satellite. I'll show you this type of process also. But this is the remote sensing process. First of all, sun is directly hit on our earth's surface, and further you can see it reflect some energy. Okay, it reflect. Suppose when it hit in the build up, then it reflects some energy, also some energy. Also when reflect from trees, it reflects release some energy. So this type of energy, it is stored on the satellite. You can see it is stored in the satellite. Okay, this satellite, basically this is the sensor. Okay, satellite have different types of sensor. This sensor collect the reflected value or emitted energy. Suppose sun, then it some emitted energy, it store it in the satellite sensor. Okay, so after that, this satellite sensor, basically from the satellite we simply collect some data. Okay, and then simply work with the data processing, okay, or computer analysis, and finally make the different types of analysis. So this is the basically from the satellite imagery we find out the your reflectance value. Okay, we find out the reflectance value. So in the reflectance value, it also called the electromagnetic spectrum. Okay. Okay, so let me show you that. Okay, just I simply write comment. So this is the basic components of remote sensing. So after that, remote sensing can be two types. Okay, suppose types of remote sensing. If you check, suppose types of remote sensing. Remote sensing, it can be two types, mainly two types. First type, it's called the active remote sensing. Active remote sensing. Second one, it's called the passive remote sensing. Passive remote sensing. So now what is the active? Active remote sensing provide its own energy. It provides own source of energy. Suppose active, I simply provide the energy. Suppose in this figure, it show the sun, but when you work with active remote sensing, I don't use the sun. I just use my own energy. Suppose I just simply make the LiDAR. So just LiDAR is one kind of active remote sensing example. Okay, from the LiDAR, it's provide the own source of energy. Okay, then we simply use the same process others. So in the active and passive, so active, it's provide own source of energy. So active, I also write in here the short note. Active, it's mainly its own source of energy. Okay, but in the passive remote sensing, use natural energy. Okay, use natural energy. Okay, so this is the basic difference between the active and passive. So active, its own source of energy. It can be LiDAR, or it can be your radar imagery. Okay, sometimes we also use the basically a lot of time we are using the natural energy, because Landsat Sentinel mode is, so this type of things is the passive remote sensing example. Okay, and use natural energy from sun. Okay, or energy like sunlight, sunlight. So this is the types of remote sensing, active and passive. So active remote sensing, its own source of energy. Example, we can say it's a LiDAR, or another example, suppose radar. And passive remote sensing use natural energy like sunlight. Okay. Then another thing is very important. So from this energy, it's called the, suppose it emitted energy it collect. It emitted energy it's collect in the sensor or receive the emitted energy by sensor. So this energy called as a electromagnetic spectrum in remote sensing, or we can say that EMS basically electromagnetic spectrum in remote sensing, okay, or EMS. So in the wavelength region, so we find out the wavelength region. Suppose electromagnetic spectrum, we find out the different types of region. Suppose for the visible region, suppose visible region, visible region, then we find out the another it's called that your infrared region, infrared region, then we find out the microwave region. Okay, microwave region. Suppose electromagnetic spectrum in remote sensing wavelength region. So this is the wavelength regions. Wavelength regions, we find out the visible, infrared, and microwave. So visible have some specific range, okay, of wavelength. Suppose for the visible, we find out the 0.4 to 0.7 micrometer. This is the range, okay, micrometer. I put the suppose m micrometer. Then infrared have the another range, okay, and infrared we find out the 0.7 from 15 micrometer range. And finally microwave basically greater than 1, okay, greater than 1, all of are the microwave. So now visible basically this visible range we find out the RGB basically red, green, and blue band. So we can see RGB. In the RGB, yes please, yeah.
So we can see that the range for the infrared region is 0.7 to 0.7 to 15, but you have said that the wavelength for the microwave region is greater than 1. So I think infrared region is 0.7 to 0.15.
It's millimeter,
right?
it's m,
Right?
it's another, okay, it's a millimeter,
Oh.
not micro.
Okay.
Okay, so we find out, suppose in this case, suppose in the visible basically we are use the RGB, red, green, and blue. It's a bands for natural color, okay, bands for natural color, okay. And then this range it's a near infrared for vegetation. Suppose vegetation is more reflected, okay. Suppose when it collect the reflect or emitted energy, suppose vegetation is more reflected, or atmospheric reflectance value is high for the vegetation in the near infrared zone, okay. So for that in this region near infrared for vegetation, because this range we find out the vegetation is the high reflectance value, okay. As well as we also use suppose thermal near infrared for heat studies, okay, for heat studies. When you identify suppose land surface temperature, so then we are just use this range also for heat studies, okay. And microwave basically it used for your radar or SAR application, okay? It used for radar or SAR, okay, SAR imagery. Basically when you schedule one, it started the SAR application. So SAR application. So this is the electromagnetic spectrum in remote sensing. We find out that wavelength range, so visible, infrared, and microwave. And then a spectral signature, it's very important in remote sensing, a spectral signature term. So a spectral signature, so a spectral signature basically find out that,
Sir, can you,
yeah please,
sir, can you please abbreviate the SAR? What does it mean?
okay. So basically this is a SAR imagery. We find out that in the Sentinel-1 Okay, Sentinel one, if you check, so let me show you that this one, Sentinel one. So this is a SAR imagery. Its full form is that you can see, I think, a synthetic aperture radar. Okay, synthetic aperture radar. So it's one kind of SAR imagery for the radar. Yeah, yes, this one. Yeah. So this is the SAR imagery. It's one kind of microwave. Okay, for this range we find out that microwave for this. So now we find out that three spectral signature, three wavelength range or region we find out, and the spectral signature basically it is material reflect or absorb the energy differently, okay, or unique. Okay, spectral. What is the spectral signature? We can say that it's is suppose is a material, or we can also say that feature or anything, any object in the earth, it reflects or absorbs energy differently, okay, or unique differently. Suppose vegetation or build up or water body, so it absorbs the different reflect or absorb value will be different or unique. So all of water, all of vegetation, every material, every features, it reflect or absorb energy different, not a same, different. Suppose for all of trees or all of vegetation, it reflect the same energy or unique. All of water is the unique, all of build up unique. Okay, so it's called the spectral signature is material reflect or absorb the energy differently. Suppose vegetation reflect high in near infrared. Okay, suppose if you check a vegetation, when you check for vegetation, this vegetation basically trees or forest, it reflect the high in near infrared. Okay, vegetation, I also write suppose reflect high energy in near infrared. Okay, vegetation reflect the high energy in near infrared, but vegetation reflect the low energy in red. Okay, so when you check, so when you practical example, when I show you that, then we will get the more easily understand all of those. So when you check the vegetation spectral signature, we find out the near infrared is very high. Okay, when you check the vegetation, suppose and red is very low. Okay, for the vegetation, when you check practically, suppose this place have a vegetation, I need to check about the reflectance value. Click on the inspector tab and click, then we find out that vegetation show the high reflectance value of near infrared, but red band show the low reflectance value. Okay, so then you can easily get same as like for water body or others. So step by step you can easily get the idea about that how it will be work. Okay, so now it's the spectral signature. So a spectral signature, you remember that it's a unique or different for a specific features or object. Just it. After that, in the remote sensing, another topic is called that your platform. Okay, so now we talk about the platform. This is the another term of remote sensing, platforms. So what is the platform? Platform basically it can be different types of platform. Suppose ground based platform, airborne platform, or satellite platform. Suppose what is the ground based platform? Suppose one platform, it's called that your ground based platform. Okay, in the ground based platform, what can, suppose it can be drone. Okay, so I simply flying a drone and take the image of my study area. It can be croplaners. So it's one kind of ground based platform. So I take the satellite imagery for my study area, sorry, drone imagery, and then I simply make the analysis. So it's a ground based platform. Okay, ground based platform. Then we also find out the another platform. It's called the suppose it's the airborne, sorry, airborne airborne. So in the airborne platform, what is that? It can be aircraft. Suppose I simply flying a aircraft, or I can simply apply the balloons. We can also use to take the this type of example for the airborne. Okay, balloons simply fly, and also aircraft. Then we can easily take the imagery. So it's the one kind of airborne platform in remote sensing. And finally, another platform. It's called the satellite platform. Satellite platform. In the satellite platform, we already know about the different types of satellite. Okay, suppose Landsat, Sentinel, different types of satellite already have in the sky. So you can easily get the information from here, or Sentinel 2 or Sentinel 1. Okay, so further satellite have different types of things. So I also don't talk about that, but this is the basic things about that. So in the platform, first platform is the ground based. Ground based basically drone. So when you fly the drone and take the information, then it's called the ground based. Then airborne. Airborne basically it can be aircraft or helicopter or balloons. And satellite basically globally or geostationary. Okay, further satellite can be two types, suppose sun, synchronized, or also stationary. But basic thing, satellite, it can be land or sentinel to it's a globally, we find out that. Okay, so this is the platform about the remote sensing. And then another important thing is the very important, it's called the sensors and resolution. So it's very important. This is the another term of remote sensing. It's called the sensors and resolution. So resolution, we already know about that. Okay, resolution basically for high and low resolution. High resolution image look more better. Okay, we already know about that. And low resolution image, sometimes it's that not look more better. Okay, so sensors and resolution. Suppose it can be a special resolution. We find out the total 4 types of resolution. Okay, so if it just first type, it's called the special resolution. Special resolution. What is the special resolution? Special resolution basically your pixel size. Okay, special resolution, it's indicating about the pixel size. Suppose for the different pixel size, we find out what is the pixel size. So basically when you zoom any image on your phone or others, when you zoom, then we find out some pixel just like a rectangle, we find out. Okay, this type of a square rectangle, we find out. So this type of things called the pixel. Okay, so okay, just I show you the one practical example. So where I find out. Okay, I'll show you the data, no problem. So basically, you find out the some square or some cell or grid. So this type of grid or cell, it's called the your pixel. Okay, this pixel. And what is the special resolution? Special resolution is the pixel size. Suppose for the Landsat, pixel size is 30 meter. Okay, mainly one pixel size is 30 meter. So now for the pixel size is 30 meter. So we find out that 30 into 30. So we find out the 900 square kilometer area. It's cover one pixel. Okay, it's cover. So Landsat pixel size is 30 meter. Then same process for Sentinel 2. Sentinel 2, we find out that basically Sentinel 2 basically 10 meter. 10 meter. Then MODIS, it can be different types of spatial resolution. Okay, MODIS, it can be your 250 meter. Sometime we find out that 500 meter. Okay, as well as for the MODIS, we also find out that 1 kilometer or 1000 meter. So if you check for the Landsat 30 meter, basically pixel size is 30 meter. Sentinel 2 is the 10 meter, and MODIS 250, and different types of spectral resolution we find out for the MODIS. So from this resolution or pixel size, which image give you the more better image? Anyone can get the idea? So from which one give me the more better image? 30 meter, 10 meter?
It's
Or
30 meter.
yes. So if
10
I
meter.
10 meter. Basically, so you also remember that pixel size. Okay. if the pixel size is high, so in this time you can see it's high, then also this type of pixel size is very high. If the pixel size is high, then it it provided low resolution imagery. Suppose in this case, this type of pixels, as you can see, 250 meter, 500 meter, 1000 meter. Okay, so this type of, if the pixel size is high, then it provides the low resolution imagery. So this image is not much good. Okay, so when the pixel size is low, suppose for the 10 meter, for the 30 meter, okay, so now if you compare Landsat or Sentinel, which one is more better? Landsat or Sentinel for the resolution? Sentinel, yeah, because this Sentinel pixel size is low. So that's why when I use the Sentinel-2 satellite imagery in my analysis, I find out the more better result. We find out the more better result or better accuracy. So it not only for the Sentinel, as well as if you check, suppose I'll show the one image, it's called the NAVE satellite imagery. It's only available for the US. So you can see what is the resolution about that, what the pixel size. Those pixel size is, okay, just I open the description, then you can see that this pixel size is only 0.6 meter. Okay, so it provides the more high imagery than Landsat Sentinel. Okay, so if the pixel size is low, then we find out the better image or high resolution image, and if the pixel size is high, then we find out the low resolution imagery. Okay, but freely available, we find out the Sentinel-2, as well as now we can also use the another image. What's the name? So Planet, I think Planet. So this imagery, yeah, I think it's also, it's a ortho imagery. So you can see it's a 0.8 meter. Okay, but this duration, you can see it's available from 2014 to 2016, not available for the present time. And this is the SkySat satellite. Okay, so we find out the one information is very important for the resolution. Okay, so if the pixel, what is the resolution? Resolution basically defined from the pixel size. So if the pixel size is high, then it provides the low resolution imagery, and if the pixel size is low, then we find out the high resolution imagery. So it's one kind of resolution. So special, it's called the spatial resolution. So now let's check the another information for the resolution. Number 2, this is another types of resolution. It's called the spectral resolution. Spectral resolution. Okay. So what is the spectral resolution? Spectral resolution basically is the number and width of bands. Okay, number and width of bands. Suppose in this case, if you check, suppose how many bands are available in the Landsat or Sentinel. Basically, if you simply go to the suppose click on the browse data catalog, then we can easily get all of image collection. If you check, we find out that Landsat, then Sentinel, then Modis, okay, all of image collection. So when I click on the Landsat, then I can get all of information about the Landsat image. And if you check for the different times it provides, suppose Landsat 1 to 5, it's provide between this time period. Okay, Landsat 4, it's provide between this time period. Landsat 5, it's provide between this time period. So every Landsat, it provide the different time period. You can see Landsat 7 ETM, it's provide this time period. Landsat 8, it's provide this time period. Landsat 9, it's provide this type of time period. So now if you check for the first time when Landsat was launched in 1972, how many bands are available? You can check how many bands number. So now further we find out this type of things. You can see, just I say click on the Landsat 1. Basically, this is Landsat 1, Landsat 2, Landsat 3. So I check Landsat 1, how many bands are available. So if you check, click on the bands, how many bands? Only green band, red band, near infrared, near infrared 2. Only 4 bands are available. Okay, for the first time when they launched this satellite, only for the 4 wavelength we find out. Okay, and you can see what is the resolution. We find out that 60 meter, 60 meter, 60 meter. We find out that only for the near infrared 2 is a 30 meter. So this is the first time. But now if you check for the present time, suppose day by day they develop their system, and further they develop the different types of bands. They are increasing the bands. So if you check Landsat, so Landsat 8 or okay, same, just I put the Landsat 9, show you that it's the present time. So for the Landsat, suppose I check for the surface reflectance imagery. So if you check now, it's provide how many we can see lens SRB1, B2, B3, B4, B5, B6, B7. This is the name, and this is the description about that. Suppose band 1, this is the it's called the coastal aerosol band. Then band 2, it's the blue band. Then band 3, green band, red band, near infrared, but short. So now you can see, find out the total 7 bands. Okay, so we find out the total 7 bands for the Landsat. So this is the spectral resolution. We find out the number and width of bands we find out in here. But this is, and it's also called the your okay, this is the spectral resolution. Okay, how many bands are available in your image collection on your satellite. So it provides total 7 bands. Now we check suppose how many bands for that Sentinel. So for this, you can see Sentinel 1 and 2. So I need to check about Sentinel 2 multispectral instrument. So you can see total 13 spectral bands. Okay, we find out the 13 visible and near infrared at 10 meters. Then we find out the red S band, or you can simply click suppose take the surface reflectance. And now you can check B1, B2. So it show the bands. Okay, lot of bands, total 13 bands we find out in here. So now what's the benefit to increasing the band number? So when it increasing the band, it means that it stored the more information. Okay, for suppose water body, then different types, and in the earth surface we find out a lot of feature. So when it increase the band number, then each feature stored the different bands pixel value, and we can easily detect. Okay, that's the region when you work with suppose mining or mineral exploration. When you work, then this type of image is not good. Okay, this type of image is not good because it's only have this type of band, not mass band, more band. So then we need to apply the hyperspectral imagery. Okay, and this type of imagery, suppose Landsat Sentinel MODIS, it's called the multispectral imagery. Only for the multispectral imagery. Multispectral imagery, we find out the some limited band. Okay, not much more information from the multispectral imagery. So I'll write about that. So for the define on the bands number, we can divide the satellite imagery 2 types. First type called the multispectral. So multispectral basically Landsat Sentinel MODIS, which have not much more band. It's called the multispectral. And we also find out the another example. It's called the hyperspectral imagery. So you can see multispectral imagery. What happened? Multispectral imagery, we find out that it's mainly show only for the few band, 7 bands, 8 bands, 13 bands. But when you open another image, suppose I show the one hyperspectral image. Aster is one kind of hyperspectral image. So simply search the Aster, then we find out the Aster imagery. So this image, you can see how many bands are available. We find out in here. You can see from the bands. So you can see we find out the total 14 bands. Okay, we find out the Aster. Okay, 15 meters. So B1, B2, B3, and B3, and so we find out the lot of bands in here. 14 bands we find out for that. Okay, and you can see this type of near infrared band we also find out in here. Okay, as well as so this is another new invention of Alpha Earth model. So this Alpha Earth model, it's also combine all of satellite imagery together. So I'll discuss about that after some time. Just a minute. So now we find out this type of spectral, hyperspectral, and also find out that multispectral. Okay, 2 types of satellite imagery. Basically hyperspectral, it's help you to identify more details on the earth surface. Okay, we can easily identify different types of mineral using the hyperspectral, but multispectral it's help you to make the land or water or vegetation. This type of feature is very easily extract the multispectral. Okay, so now another thing, this is the another types. So now we talk about that another information which is called the your, it's mainly your, this is the temporal resolution. It's very important, temporal resolution. Temporal resolution. So what is the temporal resolution? Temporal resolution basically frequency of revisit. Okay, frequency of revisit. Suppose satellite, how much time? Suppose suppose I am in Dhaka, so I have an image. Suppose 1st January. So second image when I get in the Dhaka. So how much time I need, or how much day I need to get the second image. Then third image, how much time I need. So it called the revisit. Okay, frequency of revisit. Frequency of revisit. Revisit. Okay. So suppose I have an image, I take an image in Dhaka city. Suppose 1st January. So now second image when I get in the Dhaka city, same place. So it's called the revisit. Frequency of revisit. So this revisit, it can be different types. Suppose for the Landsat revisit every 16 days. 16 days. Okay, this is the frequency or temporal resolution, Landsat for 16 days. Same as MODIS, it can be different types. Suppose MODIS, we find out the daily. So how I can check it? I will show you that. So you can simply go, you can see this is the Aster. So revisit 16 day. So you can get the information in the site, all of images. So let's check another one. Suppose Landsat, I want to check for the revisit information. Just click and check suppose surface reflectance. All of Landsat are the same revisit, 16 days. Okay, this is the revisit. It means that frequency of revisit. Frequency of revisit. Okay, suppose you check what Sentinel. What is the revisit or frequency? Just let's check. So now let's check, suppose Landsat surface reflectance, let me check 5 days. Okay, so every 5 days I find out the image for the same place. Suppose I take a one image in the 1st January, then I every 5 days, suppose 6th January, I find out the second image. So this is the frequency of revisit. Okay, then another thing is that, so another, it's called another is that radiometric information. It's called that your, okay, another types of resolution. It's called radiometric resolution. Radiometric resolution. And the radiometric resolution basically it's the difference in the energy level. Okay, suppose it can be 8-bit or 12-bit. Basically this is sensitivity to detect the difference in energy level, or your electromagnetic surface energy level. It's different. Suppose all of satellite images are not the same energy. So basically these 4 types of resolution we are used in the remote sensing: spatial resolution, spectral resolution, temporal resolution, and radiometric resolution. Okay, and then we collect the different types of images. So this is the basic things about the remote sensing. I try to explain very short time, but for the basic remote sensing, it need more than your 7 days to complete all of concept step by step to understand. But in this class, I simply show you that some basic concept about the remote sensing. So I also send you some book about that for the basic remote sensing. Then you can easily learn the theoretical part about the remote sensing. Okay. Okay, so suppose now we find out this type of imagery. So if you check, now we talk about our work in the remote sensing. Suppose I want to work with some specific images. in Google Earth Engine. Google Earth Engine have a lot of images. And previous class I discussed about the 5 types of data type. Okay. Previous class I discussed about the total 5 types of data. First type geometry, then feature collection, okay, then image and image collection. So today I talk about that. First one I talk about that image collection. Image collection. Image collection is one kind of data type in Earth Engine, okay, and another is that it's called the image. So now what is the image collection? Image collection basically set of images, okay, more than one image, it's called the image collection. Okay, more than one image, it's called the image collection. Set of images. And what is the image? Basically single image, only for the one image. Okay, and when we make the two image, it's a image collection. One image, it's the image. So we find out the two types of data in GE. So we find the two types, image collection and image. But as well as we already discussed about the another type, it's called the geometry. Then we talk about that your feature. Then we talk about that feature collection. Okay, so basically in the GIS or remote sensing we use always these 5 types of data in Earth Engine platform. So now we talk about the image collection. Okay, what is the image collection? Set of images. So now let's take the practical example. Suppose I want to work with this imagery. I want to work with this imagery. So this is the one kind of Sentinel-2 satellite imagery. Revisit day 5 days, and we find out total 13 bands. This type of bands I find out in here. Okay, just a minute, 1 minute. So this is the image collection we find out in here. So this is a surface reflectance, okay, imagery. So and we find out the two types of image, surface reflectance and top of atmosphere reflectance. Okay, so surface reflectance and top of atmosphere reflectance have some common difference. If you check, suppose in this time, when sun is heated on my object and reflect the energy directly reflect the energy directly from the surface, it called the surface reflectance. But sometimes it reflected from the atmosphere. Suppose in the atmosphere, so this it's reflected from the atmosphere, not directly from the surface, then it called the atmosphere reflectance. And what is the surface reflectance? Suppose sun is heated in my feature and directly energy directly come from this feature, so it's called the your surface reflectance. And atmosphere reflectance, it's reflected from the atmosphere, okay, not directly from the surface. So this is the common difference between the surface and also atmosphere reflectance. So we find out the two types of reflectance, so it's called the surface reflectance. And if you check another one, you can check, it's the top of atmosphere reflectance. Okay, this is surface reflectance image, it's a top of atmosphere for reflectance. Okay, top of atmosphere, it reflected from the atmosphere, but surface reflectance is reflected from directly from the surface. Okay, and take the information or take the spectral magnetic information, you take from here. Same process. Suppose click on the Landsat. Same.
Sir,
Yeah, please.
sir, can you use top of atmosphere reflectance imagery for LULC?
No, basically for the LULC, it's more better for surface reflectance. Okay, because we want to monitor the surface on the land use land cover, so that's why it's more better. Suppose land use land cover, we can also use the surface reflectance, then LST monitoring, surface reflectance. But when you identify, suppose different types of indices, suppose NDVI, NDWI, then try to use the top of atmosphere, no problem. But when you monitor directly related to the surface, suppose land surface temperature, LST, then try to use the land surface surface reflectance. Or land use land cover, try to use the surface reflectance. Okay, then you find the more better result. Suppose now I want to check, click on here. If you check, we find out the surface reflectance, top of atmosphere reflectance. So both are the same process when you work. Both are the same process. Suppose I want to work for top of atmosphere. Just click. So now it show you the all of result. You can see first of all dataset availability. Okay. So this is the time for the Landsat 8 top of atmosphere reflectance data, collection 1, collection 2. So this is the collection. So previous time it was collection 1. Okay, previous it was collection 1, but it also developed collection 2. So after some days it show the collection 3, collection 4, different types of collection, because day by day it's added the different information. So now it's the collection 2 is the update version. So we find out between this time period, okay, our image is available, and this is the data set provider, mainly USGS and Google. So USGS basically one kind of United States geographical survey. It's provide the this type of image information. If you simply search here, suppose USGS Earth Explorer, simply search, it's one kind of website. So from this website we can easily parse, or you can also download the data, different types of data we can download from here. So you can see, so this is another topic for download the satellite imagery. But now this USGS, United States Geological Survey, now it's provide the directly data in the Google Earth Engine. Okay, it's provide in the Google Earth Engine platform. So that's why we are not use this site. But previous time with when Google Earth Engine is not working, then we try to use this type of site to download the satellite imagery. So it take lot of time for the analysis. Okay, lot of, and file size is very high for the satellite imagery. So that's why now we also try to use the Google Earth Engine. Very quickly you can get, you can see this type of imagery you can easily get in the Google Earth Engine data without commercial software. Without commercial, basically it's this type of is the commercial. We need one kind of commercial software. Okay, also you can see this type of digital elevation model, or also get that all of Landsat imagery we can easily download from the Google Earth Engine. So let's go try to discuss about that Google Earth Engine. But this data provided by this site. Okay, this data in Google Earth Engine, it's provided by USGS and Google. Okay, provide and this is the snippet ID. Snippet ID basically like as a directory. Okay, directory, suppose this is the folder directory. So when I go to this folder, then I can access this image collection. Okay, and this is the snippet ID, and if you check, it's a ee.image collection. Okay, ee.image collection, then provide the snippet ID. So now this how I can import the data in Earth Engine platform. Very easy. Just you can copy, just copy this snippet ID, just copy, and then paste on your code editor. Just I copy. So now you just define a variable name. So how we can define the variable name? Very easy. Before the name, just use the var keyword, va, and then put the variable name. You can name. I put the name, suppose L8 equal. So now this image collection, it is stored in this variable L8. Okay, and if you check, it's the image collection. And what is the image collection? Set of images. So this directory is stored all of images, not for the single image, because it's an image collection data. So now I want to check how many images are available in this collection. In this collection, how many images are available? I want to check. So let's go. For that, just use the print function. I want to print the L8 because L8 is stored this image collection, and use a function. Just a minute, I connect my laptop charger. Just so I want to check how many images are available in my collection. So just use here the dot size function. Okay, so now it's computing how many images are available. Run the code. So now you can see in the console tab, number computing. So now it's computed how many images are available in your collection. So anytime, suppose you have a collection, image collection, you want to check how many images are available in this collection, just use the same process. Use the size function. And another thing is very important. You can also find out, suppose click on the docs tab and you can check ee.image collection. ee.image collection is one kind of data type. So in this data type, I can apply all of function. Okay, in the all of function only used for image collection data type, I can easily apply. So if you check, this is my image collection and I apply the size function. Now let's check size function is available in this section or not. So let's check, we try to check it. So where is the size? You can check where is the size. Size function. Okay, so all of function are available because size function I can use in the image collection. So this size function is also available in this section. So in this section, all of function I can use for the image collection data type or use for image collection for the different purpose. Suppose if you check what is the size, click on here. So you can see this size function return the number of element in the collection. So in this collection, how much images are available, it show you these things. Okay, so we find out very large number of image collection. Okay, so this is the total image collection are available in here in this directory or in this snippet. Total, this is the large number of image collection. Okay, we find out. And time period, what is the time period for this image collection? So we can check it from here. This time period from year of 2013 to 2025 08/18. So between this time period, how many images I find out in the Landsat 8 collection 2 tier 1 top of atmosphere reflectance. This is the total number of image collection globally. It show the globally. Okay, so now this is my full image collection, but now this image collection I want to filter. Okay, and choose for a specific boundary, a specific shapefile, a specific area or a specific geometry. So this image collection I want to filter, and this image collection I need for a specific geometry. So how I can filter? So first of all, I will just explain this theory. First of all, you remember where you need the image, where you need the image, where you need image, or where you need the image. So stay right, where you need the image. Second, how you need this image. Then when. Okay, so just use where, how, and when. We simply filtering our image collection. So this is my image collection. It show you the result for globally all of the whole earth. I find out this the number of image collection, but I don't need for the whole earth. I need this image only for a specific study area. Where I need this image, suppose I need the image in suppose Dhaka city or any specific ROI, no problem. Okay, and suppose let's go try to check it. So this is the total number of image collection for the whole world, but I need the image only for Dhaka city boundary, only for Dhaka city boundary. So how I can filter? Just simply upload your Dhaka city boundary shapefile. Okay, or you can simply, I simply show you that from my asset. So I already imported the shapefile. So just click on the asset tab. And if you check, where is the Dhaka city? So here I already uploaded. So let me check. Where is the Dhaka boundary? Dhaka. So this is my asset. I already uploaded this shapefile. Okay, just click on this. Click on here. So now you can see a new line of code added in here. Table. Okay, show the feature collection and show that's my ROI. So now for this ROI, I need this image. Okay, for this ROI is stored in my shapefile of Dhaka city. So for this ROI, I need this satellite image. So for that, how I can filter? So just use a function. You can check this function called the filter bounds function. So I'll show you the function first. Filter bounds, you can check. So this is function, filter bounds function. Mainly it's shortcut to filter a collection by intersection with geometry. In this case, my geometry is Dhaka city. Okay, and I have this collection. Large number of collection. But now I want to intersect with my geometry and check how many images are available in the Dhaka city boundary. Okay, so I need to use the filter bounds function. Just I copy filter